my co-organizers, Antonella Tomasel and Arcais Zubiaga, we would like to welcome you to this first edition of the workshop of online misinformation and hardware recommender systems. We would like to remind you that for today we have 2 invited talks. I will introduce the first one just now, and 5 papers presentations. For the first talk, it is a pleasure to me to introduce Barbara Poblete. Barbara is an associate professor of the Computer Science Department at the University of Chile. She's also a researcher at the Millennium Institute for Foundational Research on Data, where she co-leads the Fake News and Misinformation Multidisciplinary Research Group. And okay, she will be talking about mining social networks to learn about rumors, hate speech, bias, and polarization. And, okay, without further ado, I will leave you with Barbara.
Okay, thank you. Okay, I'm going to share my screen. Let me know if you can see everything okay. It's starting.
Yes, I've seen it.
Okay, great. Okay, so thank you for inviting me. I'm very happy to be at RecSys in this workshop, which is very ad hoc to the research that I do. So a little bit about me, so you get a bit the context of where I'm coming from. So I'm a data mining person. I have been, now data mining is called data science, but it's actually has existed for a couple of, like a lot of decades now. And I have worked on information retrieval for a very long time. So I worked on the first search engine in Chile before we had Google here. So I have done all that. I have traveled from information retrieval and then to doing data mining, and now I specialize on web data mining. So I used to work at Yahoo Labs in Barcelona and in Santiago. And when I moved to academia, after I was in industry, I found that I didn't have as much usage data as I did before. And that's when I started looking kind of at social media data. I'm not an expert. I wouldn't say I'm not a developer of machine learning tools. I use them a lot. So I know a lot about evaluation in machine learning, but I use it mostly to discover knowledge. I'm not an expert on RecSys either, but I think both machine learning and RecSys require a very good understanding of data and can learn a lot about data. So that's kind of what I want to bring to this talk now. Overall, I value gaining understanding from data, being able to reproduce and generalize results more than gaining marginal improvements. So a very general context about the social web, in case you're not an expert on social media, I guess this is a broad audience, is that it created a shift in how we study the web and how we interact with the web. So before the social web, what we did was that we were like passive surfers, that we were going from one page to another, more or less consuming content. And after the emergence of the social web, what happened is that we became producers and editors of our own content. And this created an explosion of the amount of content on the web, of user-generated content. So there was a big paradigm shift, you would say. And a lot of scientists from many different fields are looking at with much interest into the social web, because it gives us a look into a portion of society. So it's a very biased view, but it's still quite interesting. So I have had the chance to work with journalists, with psychologists, with political scientists, with physicists, economists. All of these people are looking at the social web because we can learn a lot about human behavior from it and things that are going on in the real world as well. Another thing that I find super interesting as a computer scientist is how the social web has become this new information media. So basically, we have dropped all other ways of finding information and have concentrated on social media in the past years to have late breaking news at our reach within seconds since it happens. And it also has become a communication media for us. Like, we can interact with people all over the world, and I can participate and meet people from many different cultural backgrounds. So there are like no barriers. So we're culturally changing thanks to this new information media. The quality that I think makes it more special in this case of Twitter as a platform is that it can provide real-time information from the place of events. So since you usually carry your social media in your phone and you walk around with it, if you see something happening, well, we don't go out much now because of COVID, but when we used to go out a lot, then if you would see a car crash or something, you could like take a picture and upload it. And this was instant. And you could comment about anything that was going on in your environment and put it online. So this, for me, is really valuable. And basically, Twitter is like a preferred source for its users for information, real-time information. And this has created an emergence of what we call citizen sensors, in the sense that we are all sensors, like physical sensors, like earthquake sensors, but it's people that are connected to this giant network, which is the web, in which when you see something, you can talk about it and you can post about it. So if you see an earthquake, you feel it probably, many people immediately will post something about it. And the thing is that there are just so many users that one of them will be sensible enough to the phenomena that is going on to talk about it. Not maybe there is like a natural filter. Maybe some people are more sensible to earthquakes than others, and the most sensitive people are going to post about very low intensity earthquakes on the web. And then you have other people that are maybe more sensitive to political events and they'll talk about those. So we have sensors for everything, and it's us. This is an example of like immediate information. This is a kind of old example. So it's like the water landing that happened on the Hudson River. You may remember it from the movie Sully. But it actually really happened. So in the first report, this first picture that we see over here is from the US Airways flight that landed on the Hudson. And this picture was taken from a ferry by a Twitter user, and they posted it online. And this was the first information about that event that happened. So this illustrates how users have become creators and publishers of their own content. This is another example. So this is a Twitter user that was talking about a rare event that was happening. So helicopter hovering above Abbottabad at 1 a.m. And what he didn't realize at the time is that he was live tweeting or live blogging the Osama bin Laden raid. So this was the first person to inform publicly about this happening. So the other thing is that we can't really say that there is a direct correlation between the impact that an event has in the real world and the impact that it has in online social networks. These are not necessarily related. So there's a bias in that view. There's a bias in the reaction that we measure in the online social network. Like if we only look at social networks, we'll think that some things are super important and maybe in the real world, they're not. So here's an example. This is how many tweets were tweeted per second, how many Twitter messages were posted for different events. So this is Hurricane Sandy. We had like 200 tweets, almost 300. Boston bombings, a bit more, like 700. Japan earthquake. And these are like huge events with a high cost in human lives. And we had then the Pope elected in 2013, Super Bowl 2015, World Cup final, thousands of tweets. And then we have also the broadcast of an anime series on Japanese TV, Castle in the Sky. And this was like much more than all the rest. So it doesn't really reflect the impact on human lives that an event had, how many tweets or messages people are posting, or how how much activity it generates online. Social media has many, many advantages, and also, as you saw in the RecSys keynote, is that on the main keynote is that it has made us very vulnerable to how online information is shaped. And this is very important, because now that we have a lot of advantages, we have to lead on how it has made us vulnerable to the selection of information online. So there's this phenomena that you're probably familiar with, which is fake news, which is fabricated information that mimics news media content. So it's made to appear as real information. And you have misinformation, which is something that was maybe real, but it's phrased or framed in a way to mislead. There are different types of misinformation in Twitter. So we have non-malicious and malicious misinformation. We have hoaxes, and we have, for example, intense non-partisan activism, and we have political partisan astroturfing, which is now more related to what we see as fake news. And we have commercial spam, and we also have hacked accounts. We have, for example, this is the example on the picture is the hack of several famous Twitter accounts in which they were asking for donations in Bitcoins. And this was a hack, and people actually donated money to this. But this goes back a long time. So this is from 2011, January, when there was a false alarm of a shooting in Oxford Circus. So a lot of people started asking about this. If you look at the first messages that were posted, people were asking, was there a gun alert on Oxford Circus right now? Is there a shooting? So there's a lot of questioning about what's going on, and people are asking. And some people are saying that news media is really dropping the ball because they're not informing on TV about this event that is going on. And then towards the end, people start to realize that this is a hoax. And somebody says, okay, Twitter, a social networking and microblog service that helps breed and incite panic with conflicting reports of a gunman at Oxford Circus. So this happens in many different scenarios, and it has been going on for a really long time. So this is 2011. If we do a flashback 9 years ago, with my colleagues at Yahoo, we were hit by inspiration to study information credibility on Twitter. So before this article, there hadn't been other people studying this problem. This was not really a problem in social media. How did we come about this? How were we hit by inspiration to study this problem? Well, we were literally hit by a huge earthquake, which was the earthquake in February 2010. And it was like the 8th largest earthquake in history, and it was huge. Like if you were, I hope you were lucky enough not to be in Chile at that time, but it was really this amazing event. I was here and I thought the world was going to end at that when it was happening. Actually, that was my feeling. And the thing is that it was so massive that communications were lost for 2 to 3 hours. And the first video images appeared after 6 to 7 hours. So there were no formal communications. And the team that we wrote this paper and we did this work, so we were all Chileans and working at Yahoo, but Marcelo and I were working in Santiago, and Carlos was working in Barcelona. And since he's Chilean, he was very concerned about us and his family in Chile, but he couldn't find any information. The only thing that remained functional was Twitter during that period, because for some reason the international connection worked and people could tweet, but we could not communicate internally within the country. That was very strange, and I have talked about people from telecommunications about it, and they have told me that is the actual phenomenon that happened, was that the international connection worked, but not the national connection. So we were able to post things on Twitter, but we were not able to have access to national information and corroborate what was happening. So we did, basically we started doing a data exploration. about what happened during the earthquake. At that point, we had all the Twitter data available to us. And we started looking first at this hashtag that was called Terremoto Chile, which means earthquake Chile. And we saw how messages propagated with the hashtag within the first hour, and then the second hour, and in blocks. I think these were blocks of 2 hours. And basically these are how you send messages and communicate among each other. And other exploration we did was look at the days after the earthquake and see how conversation topics were changing. So the first day, everybody was very concerned because people didn't die from the earthquake. They actually died because we had a subsequent tsunami that wasn't warned. But if you looked at the Twitter data, people were posting on Twitter that they were seeing the ocean pull back, which is an indication of a tsunami. But the National Guard and actually the president said there was no tsunami warning. But if we had like alarms using Twitter data, we would have been able to realize that there were a lot of people from different places along the shoreline telling us that there was going to be a tsunami. So there is value in social networks. We just need to know how to find it. And that was the first day, and a lot of people died because of the tsunami. Second day, a lot of people were lost also because of the tsunami, and people were trying to find them. And then topics started shifting and asking for help. And then there was talk about like the axis of the earth moving and like shifting. So this is the conversation topics. What we found like in our exploratory analysis was that the large majority of tweets were very helpful, and people could be informed because of this, because some tweets were not helpful at all. So there were a lot of rumors, and this was the first time that people were observing like rumor propagation on Twitter in 2010, like officially observing it from a scientific point of view. And we saw that, okay, celebrities, public figures were like killed. And also there were other false tsunami warnings. And since the first tsunami had been so harmful, this created a lot of panic, and people even had heart attacks from this. There were also false reports of looting. I remember outside my house, like nobody went to sleep. Everybody was watching their house because you didn't want like to be a victim of this. So what we did was that we identified the different topics like automatically that came up in the conversation of the like next 4 days after from the occurrence of the earthquake to the next 4 days. We manually inspected the topics of conversation, and we found that now that at the end of the event we had all the information, we knew that some of these things had been confirmed truths, and other things ended up being false rumors. And so we classified them, and we identified manually some features that we thought would be interesting to look at. We found number of unique tweets, percentage of retweets. Retweets is a share of a tweet. Number of people that would confirm the rumor, number of people that were denying the rumor, and number of people that were questioning the rumor. So we were able to identify some patterns just by looking. Yeah. So in data mining, what you do is you always have to look at the data, and you always have to explore your data before doing any other research on it. And we found certain patterns. You have to remember that there were no other sources of information. So people were only using Twitter during that time period. But for the confirmed truths, what people rarely denied the information. So people would rarely deny the information when it turned out to be true. And people rarely questioned the information as well. But for rumors that turned out to be false, people questioned it, denied it a lot, and they also questioned it even more. So this kind of talks to us about an automatic or natural filter that arises in the social network. Like when you look maybe at one message or a few messages, or if you just look at your friends, you might be tricked into believing something that is not true. But when you look at the collective of everybody, you can tell that the network is able to give you a filter of what the collective intelligence thinks that is true and is going to end up being true, and what it's not. So this was just from the exploratory analysis in 2010. And so we asked ourselves the question, can we automatically detect false tweets as events are unfolding? What do you think? Like, I don't have audience interaction, but usually when I ask my students this, what they say is, yes, you can. Well, not really. Like, we can't really see the future. I mean, if you're during a crisis event and you don't have access to any information and the event is actually unfolding, you don't know what's going to happen in the end. So we can't really tell you what is true or what is false when an event is unfolding. So that's something to keep in mind. But what we can do, and what we did with, we found with this exploratory analysis, is that there is a perception of what information is credible or not by the collective of the social network. And credibility is a perceived quality of multiple dimensions. So an article can have a different perceived credibility depending on whether it was written by a male or a female author. We see that in academia a lot in studies about scientific bias in reviews. Also, the same happens with tweets. If they were written by a male or female author, or a headline, if it was written by an official news media, or by a simple Twitter account, or by a very popular user or not. So what the task we did was, okay, so let's try to see if we can create a classifier, at least to tell us if the network finds it credible or not credible. So what we did a giant mechanical Turk task in which we showed topics to different Turkers with a sample of their tweets, and we asked them to tell us if they thought the topic was newsworthy and if it was credible. If it was newsworthy, and if the topic was newsworthy, then to tell us if that information was credible based on the tweets that we were showing them, and even if they had some background information to know if it ended up being true or not, or if the links had URLs, they could actually visit those URLs. So that's how we built our ground truth. And we created our classifier, and we found that we could predict very well if something was newsworthy, and also if it was credible. Yeah, we had very good results, and we used the text of the messages. We used like hundreds of features that we have. Like, if you're interested, you can look at the paper. And we used network features as well. Propagation, like the depth of the propagation tree, and top tweet elements, like if it had a URL, if it mentioned a user, things like that. We even showed that our model could be used to classify events online as they were unfolding. And we even transferred this model to Spanish, and it worked quite well. So those were our findings at that point in time, a very long time ago. We found that the less that you rely on external sources, the more likely you're to believe on false information. So if you trust only your social media, then you're very likely to fall prey of false information. Also, that credible information was propagated, like information that was felt to be credible was propagated by more prolific and well-connected users. Tweets that had URLs in them were found to be more credible as well by the social network, specifically if they were from a popular domain that everybody knew. And information looked more credible if it didn't have exclamation marks, and also it looked more credible if it was negative. That was one of the findings. So now we move back to this year, 2020, and that work that I described was the first of thousands of works that in academia that address credibility of information. So the question I find myself asking constantly is, how can we be worse than ever at this point, at a point where our democracies are being challenged, you know? Well, you're in RecSys, so you're all familiar with this. This is filter bubbles. So I think we have filter bubbles to thank for that a lot. When we did our study, Twitter was not recommending content, and And we didn't study Facebook at that point, and I think there was not such a strong influence yet of filter bubbles. But basically, if you're not familiar with the concept, this is a study done on Facebook data by Facebook, where they found that our selection of friends would limit our exposure to divergent content. So basically, when I select the people that I friend on Facebook, I'm selecting people that are very similar to me. So I'm exposed to content that agrees a lot with my values and things that I like. And then if on top of that, you put the recommendation system that further filters the content that it's showing to you, it will even optimize something that is already very similar to make you engage more with the platform. So when you're there, you're even further reduced to more divergent content. So this increases the probability of accepting only news that are compatible with your own ideology, and it's also set to reduce your tolerance to views that are different from the ones that you have. So this is filter bubbles, and also the effect of echo chambers. We see this a lot in Twitter and also on Facebook, where they have done a lot of efforts to remove the amount of bots. But basically what bots do, automized accounts or even paid accounts that are not that automized, is that they amplify the extremes of the spectrum, of the political spectrum. So basically you get, when you look at social media, many people tell me when they go on Twitter, they feel that the world is on fire, because everybody is kind of arguing with each other and they're very extreme opinions. But the reality is that it's not necessarily like that. The thing is that you have very amplified the extreme voices on one side and on the other because of bots. And also those users are way more prolific than the rest. And then you have the more moderate voices that still exist and are many users, but are more quiet. So this is actually an illusion, but this is what you get when you look at social media. And it is said that the political polarization has increased since the 90s from 20% to 70% in the US, according to the study. So I'm clicking this animation. I hope you can see it. So it shows how political polarization has increased over time. And they define political polarization as, for example, Republicans having a negative opinion of conservatives and vice versa. So if you ask people, they asked people in the 90s, and only 20% had that polarization feeling, and they ask people now, and more than 70% had that polarization feeling. And this is very harmful to democracy because it creates this view of us against them that radicalizes political actions and discourse, as we are seeing currently in several countries. And something important to keep in mind is that we tend to share information that is consistent with our values. So this makes us more likely to share fake information if it agrees with our values. This was a study also done by people, I think, at Facebook, in the sense that they found that Republicans and independents were much more likely to share false information than other groups. They also found that people that were over 65, they were more likely to share fake news. And this is on Facebook. I don't know other platforms. Maybe younger people are not on Facebook anymore, but over 45 and then over 65 share a lot more fake news than the rest. They also found that people that identified themselves as conservative or very conservative would share a lot of more fake news. So this is, you're not as likely to be target, or not to be a victim or to propagate fake news. Not everybody's as likely. So more conservative people are more likely and older people are more likely. I don't know if maybe you saw this documentary, which is called The Great Hack. I really like this documentary. It talks about how Facebook is the leading misinformation platform in the past years, and they show how and this has also been corroborated by other studies, in that more than 70 countries have had disinformation campaigns that have been detected, and that Cambridge Analytica collected private information about 87 million people around the world from Facebook users. And this allowed them at that point to create highly detailed profiles about people's preferences and design political campaigns. So this is all part of how you recommend content, but you recommend content with the goal of changing a person's actions politically. So many of us have tried to understand this phenomenon. So Facebook at some point, 2017, announced grants. This was announced with a lot of publicity, grants for research on social media and democracy, research grants. It wasn't really announced so much by not only Facebook, but this was in association with Social Science One, which is an independent organization, and they made an agreement with Facebook, and Facebook would provide data to researchers that were awarded these grants so they could investigate and understand the effects that Facebook had on democracy. So our research group applied for 2 grants, and 12 were granted worldwide, and we got 2 grants to investigate the effects in Chile of Facebook in our elections. And we started working on that. We went to training, everything. And then what happened is that we actually, there was so much anonymization done on the data that we receive, and that's understandable. I mean, you don't want to have another Cambridge Analytica or data leak about users, but there were so many impositions on the data that we ended up not being able to find anything. The signal was so lost in the noise of the data that we got. So basically, we have been working for like 3 years trying to extract something useful from this data, and it has been impossible. And this is a very complete team of researchers from political science, social science, computer science, physics, and also from the 12 other grants, and nobody has been able to extract any data. So this tells you something about what is the willingness of big companies for us to let us understand the effects that their platforms are having on democracy. I can't say that all platforms are doing this, but this is something that actually happened to us. Some conclusions from how we have arrived to this situation is that, from my point of view, we have stopped to the situation of fake news and democracy erosion that has been going on lately, is that we have stopped trusting traditional news media, and now more than ever, we rely on social media for information. So there's a lot of people that get all their news from social media, and I can't really, maybe my colleagues from communication can explain why people have stopped trusting traditional news media. That's like a different problem. It's not necessarily social media's fault, you know? And then you have algorithms that optimize in the platforms. You have algorithms that optimize user engagement and are biased towards fake information, because fake information increases user engagement. And this is the goal you want to optimize. There are no incentives for the platforms to change this. So we maybe have to think about finding the right incentives to provide the users with trustworthy information. I mean, that's your goal in this workshop, I hope, as people from the RecSys community. Also, something I think is super important here is that we need a multidisciplinary approach to target fake news. This is not a problem that technologists can solve by themselves, and we should not frame this problem as something that technologists will solve or are going to solve by themselves. Like there is an interview of Mark Zuckerberg that says, they ask him how he plans to solve this problem, and he's like, I will create an AI that will identify fake news and then I'll remove it from the platform. This is not what we have to do. I mean, we have to get a multidisciplinary team to work on this. It's a very complex socio-political phenomena that we have to study. Another thing that I want to briefly touch in this presentation is the matter of hate speech detection and bias. Hate speech is also a very a multidimensional information disorder that is happening in social media and in society right now. So why do I think that it's like important? Well, there was the study from Amnesty International about how Twitter was a toxic place for women. And what they showed, they did a study with female politicians in the UK, and they found that they received like orders of magnitude more hate speech and replies of hateful content to them when they were trying to do their political campaigns. So basically their voices were like shut down. Voices of women in social media are shut down by hate speech. And this can be seen as a matter of human rights, because everybody should be able to express themselves. And if you can't conduct a political campaign on social media because you can't express yourself, then you're in a great disadvantage when it comes to being able to get elected. So then it can turn out in the effect that women are not as elected. So it needs to be addressed. And what we found, so we started looking at this problem of hate speech detection, and I had a student I met, and she was very concerned about how to do this in Spanish, because we found that everything was done in English. And we saw that when she presented her thesis topic, what the professors in her commission said, why do you want to study this? This is a closed problem because it has already been solved. And we had systems in the state of the art that were reporting like 97% F1 measure, like they were getting everything right. So we said, okay, what we're going to do, since results are amazing for English, we're going to do transferring learning from English to Spanish. And we got really, really bad results, like worse than random. We couldn't understand why. So we went back to the studies in English, and we tried to reproduce all of those work, and we were not able. And this is kind of coherent, because you get that the scientific literature is reporting a close to perfect state of the art for hate speech detection, but then you see that online platforms are having, this is one, like if you talk to somebody at Facebook or you talk to somebody at Twitter, they will tell you this is one of the hardest problems that they're working on, is hate speech. So there have been like a lot of problems with that. And we conducted a study with my student Aime, my colleague Jorge Perez, and we reviewed the entire literature of hate speech detection for social media. And what we found was that there were errors in the existing scientific works, because they had faulty experimentation. So they had done poor experiments, and they had bias in the learning data set. They were all using the same data set, and this data set was hugely biased. So the problems that we identified was, for example, and some people just don't believe this, but we found this in published papers in very good conferences, was that they were using the complete data set for training. They were not doing the train and test split properly. So they were using the complete data set, for example, to learn to generate the word embeddings. And then they were using this for the training phase. So you were transferring information from the unseen data from your evaluation to your training phase. The other problem that we saw was that they had very little examples of hate speech. So they were doing oversampling, but they were doing oversampling before the train test split. So then basically what you had were the same examples in train and test. So there was a huge overfitting problem. They were learning the data, and this is why they were getting such good results then in their evaluation. The other bias that we identified, this is a course of several works that we study, was that they were all using the same data set, most of them, and it was posted based on Twitter users. It was posted only messages and did not have the user information. So we actually wrote to different people asking for the user information. Some of them provided, others said it was unethical to try to get user information. But we ended up being able to map the tweets to users, but not because we wanted to know who posted it. We wanted to know if somebody had posted more than one message. And we found that 90% of the hate speech messages in the data set had been generated by only 3 users. So basically what they were teaching the neural network was to learn to identify users and not to identify hate speech. And this is why you couldn't transfer any knowledge from here. Why did we find these problems? By having multilingual needs. I mean, if we hadn't had the need to make this work in Spanish, we would have not found that the literature in English was wrong. So one of the lessons that you learn is that you always have to look at it from a completely different angle. Overestimation of the state of the art is more common than we think, especially with deep learning techniques, because they have become so obscure that people lose a sense of what they're really doing and lose track when they're doing their experimental evaluation. Also, in machine learning, sometimes people don't pay attention to the data. And important lessons here is that you always have to look at the data. And also I would say you can't really say that you've solved a problem until you have successfully applied your solution or method to a completely different scenario. I mean, doing a train test split on one data set and said that you solved a problem is not solving a problem. Some closing thoughts. Well, I still think there is a lot of value in online social networks. I think they're a really great thing. I think we need to provide tools to make good quality, aggregated, like from the aggregated, extract good quality content and make it available to users. I think that's our task, not to kind of take the user out of the filter bubble, but not by showing them things they don't like, but extracting value from the collective and doing new tools to do this. Things that we have done, we do earthquake detection based on Twitter, and it has worked extremely well. And we do it for many different languages. It's very fast, and they use it in the National Seismology Center in Chile. We do Mercalli estimation as well, though this is the system. You can look at the paper. We also have, that's twicali.cl, is the seismographer based on Twitter data. We also have Gallian, which is a way to explore news in Chile based on social media, but shows you aggregated information about it. So those are just some ideas, but I'm out of time. So that was my talk. Thank you very much.
Thank you very much, Barbara, for your talk. Very interesting questions. Let me say that we have the Q&A session. If you want, to the audience, if you want to leave there some questions. I would like to ask you something about, you mentioned at the beginning, the problems with Spanish and probably with not English tests. So most of us working with Spanish and Portuguese, probably there's a lack of resources for doing data analysis. And what do you think we can learn from other or use from other languages to apply, or multilingual approaches? If you can talk a little more about that.
Yeah, so there are like 2 lines of research that we have been trying in our research group. One is to have like language agnostic approaches, for example, to identify hate speech without relying on language specific things. Like, for example, we have been using universal language embeddings. This doesn't work very well yet, but we're tuning it. We're trying to kind of learn universal patterns of hate. For example, if you think maybe one group is discriminated in one country and you see this sort of pattern repeat itself in other countries, how can we identify these patterns to learn from the data? So it would be like language agnostic approaches is one way. The other one is that we have started building resources, like massive amounts of resources for Spanish. I'm going to share my screen 1 second. Again, let me hang on. I had a slide. Share screen. I don't know. Can you see my screen?
Yes.
Okay. So we have some resources for. I see it all white for some reason. So Okay. We have resources for, maybe there you can see it, for Bert.
Yes.
We have trained, my group has trained Bert in Spanish. And this has been a huge thing, and it's been used in academia and industry. We have also created tools to identify bias in embeddings. And also we have created a multilingual data set for hate speech detection. So what we're trying to do, like what we would try to do at a regional level, is to kind of join forces and start creating all of our own resources. So those would be my kind of advice in that sense.
Yes, and most data sets are in English or in, so
yeah.
Bill in Spanish is also Portuguese, so another language would be useful. We have a question from the QA, from Marcus. How do you think we could achieve more reproducible research in the area, since often the access to the data is restricted?
Yeah, so what we have tried to do is that we always, for example, if we have a data set that we cannot share, we always have to try on different data sets. Like we cannot publish something that has, or findings that have only been done on one data set. We have to at least have other public data sets that we can reproduce similar findings. And we always publish everything we do. I mean, we have the GitHub with all the code. For us, it has been super hard to reproduce other people's work. So we try not to reproduce the same errors. We publish oral data sets, and with Twitter data, you can't really publish it directly. You publish the tweet IDs, but we leave the scripts. So you just have to press like click and it will download everything for you. So you get the same setup. So I think it's our responsibility when we review work, we need to make sure that the work that we're accepting is reproducible, that they have left the resources for the communities. When you have your workshops and we organize conferences, we also have to worry about reproducibility. I think it's a community effort in that sense.
Okay. And if you have considered to work with multimodal data for fake news detection, or because it's also a problem to consider images, the combination.
Mm-hmm. We have considered, but we have like mostly addressed it from different modalities, not integrated in my group. I know some people are. There is a group of people in our research team that are using like memes, you know, to kind of try to see when they're like hateful or not, and things like that. So they're using images and extracting the text from the images to combine both things, but we haven't advanced that much. For us has been text and network properties mostly, and also user metadata, what we use. So it's kind of multimodal, but not necessarily with images.
Yes, right. Okay, if someone has any other question or want to post it in the QA. Regarding bias, you talked in the last part about what kind of bias you were addressing in your work, because as we know for the first keynote speak, the second bias IH keynote, there is bias everywhere, different kinds of biases. You were working in the hate speech data set. What kind of bias you were observing?
So for us in the hate speech, it was mostly addressing the user bias, because there are some users that like are very prolific at generating hate speech. So when you go and look only at those users, basically you teach your machine learning algorithm to learn who those users are, and then you're not able to identify new emergent hate speech topics or hate speech in other contents. So the other bias that we address a lot is the bias towards the English language. I mean, we're always trying to find how to transfer things that have been done in English to Spanish and to other languages. Those would be the main biases in representation. So it would be the misrepresentation of things that we need to use.
Mm-hmm. Okay, and last question maybe. In the beginning of the talk, you mentioned about rumors and the relationship with the earthquake in Chile, and I was wondering about how to automatize the alarms for this kind of events, because things are happening in Twitter, and you cannot capitalize on the real world. And if it can be automatized, that the alarms, no? I was thinking because of the serious consequences of false alarms in those cases. No?
Yeah, so we have automatized the alarms for earthquakes, like in the system that I had shown to you before. Let's see. In this system that I showed before, do you see it? Right. Yeah, we have this red dots there. Those red dots are alarms, but we trigger them not with machine learning, but with statistics, basically. So we see that when there is a big spike in the conversation related to earthquake topics that deviates a lot from what we had seen in the past statistically, then we place the alarm, because it was hard to learn from the data, like teaching it by example. It was easier just to do a statistical test. But this is meant, all the systems based on social media are meant as tools to support decision makers, not to be the only tool to make decisions. So for example, the National Seismology Center uses this so they can describe better an earthquake. They have their own seismographs, but the seismographs that they have are very sensible. So they basically sense earthquakes all day. And the only way that they can tell if people felt it is by looking into the Twikali app, and they see, okay, somebody felt it because they tweeted about it. So it's like it's to support decision making.
Yes.
But you always need the expert in the domain to look at the data.
We have to keep the human in the loop.
Yes, of course.
Of course. But sometimes in Twitter things happen and people start using that information for taking decisions and directly, and kind of difficult. Great. Barbara, thank you very, very much for your talk, and we will continue with the next presentation.
Okay, thank you. Thank you for inviting me. Bye.
Okay, and then we have a paper presentation by Alejandro Bechoguin from the Universidad Autónoma of Madrid. His work is on recommender systems and misinformation, the problem or the solution. So we are seeing already the presentation, Alejandro.
Okay, thank you. So you can see the slides.
Yes.
Okay, perfect. So thank you for the presentation. Well, hello everyone. My name is Alejandro Bechoguin, and I'm here to present this position paper describing some ideas that Miriam Fernandez from the Open University and me are starting to work together related to recommender systems and misinformation. Now, after the keynote, the first thing I want to say is also I want to thank Barbara for her great talk, and also because she's going to save me some time for some concepts, because as you can imagine, they are going to be related at some point, because I'm going to also talk about misinformation. So in particular in this work, what we aim to analyze is the effect of recommender systems in spreading misinformation. And for that, we will introduce 4 research directions we believe are critical for this problem and the challenges we foresee in the process. So first, I was going to motivate why misinformation is important, but Barbara presented this with many more examples, so I'm going to skip it, but just the main idea is that misinformation is still quite common in the media. And actually, just in case you don't know it, in 2016, the term post-truth, which is used to talk about misinformative news items in the political context, was chosen as by the Oxford Dictionary as the word of the year. More recently, in the context of the coronavirus, we have observed several examples of misinformation in the media. So these are just other examples complementing those presented by our keynote. On top of this, there are several factors that influence the spread of misinformation online, including first, the ways in which information is constructed and presented. Second, the user's personality, values, and emotions. Third, the architectural characteristics of the digital platforms where such information is spread, such as the structure of the social networks or the constraints on the type of messages or sharing permissions. And finally, the algorithms that power the recommendation of information within those platforms have an obvious effect on how information, and of course misinformation, is spread, as other colleagues have discussed several times in this conference, and in particular in the first two keynotes. So in this project, we care about the last point I mentioned, that is that we want to explore the effect of existing algorithms on the recommendation of misinformative items. While multiple works have concentrated on studying the effect of different types of information, users, and digital platforms on the spread of misinformation, we argue in this work that there is a need to further explore the effect of these algorithms. The main reason for this is that the feedback loop that we have represented in this figure, which is usually criticized since it evidences that recommender systems reinforce filter bubbles and echo chambers, but how do they actually affect the spread of misinformation? So in particular, we argue that a more in-depth investigation is needed to better understand which techniques among the recommender systems algorithms are more prone to spread misinformation and under which circumstances. And assuming we are able to have some decisive answer for that, we aim to continue our investigation by studying how can their internal functioning be modified or adapted to counter this behavior. So it is also important to highlight that finding a correct solution for this problem is not obvious. Social platforms have tried to break the echo chambers created in this mentioned feedback loop in different ways. Here I show you two examples from Twitter and Facebook. For instance, Facebook created a tool that provides more context to a story by showing related articles. With a similar idea in mind, Twitter started recommending popular tweets into feeds of people who did not subscribe to the accounts that posted them. However, both approaches turn out to be not perfect solutions. On the one hand, the related articles from Facebook inadvertently hide critical information that explain the inaccuracies, which backfire by entrenching a person's false beliefs. On the other hand, the approach of providing popular but opposing views was heavily criticized for amplifying inflammatory political rhetoric and misinformation. In fact, research shows that it is not enough to show people corrective information, since they may struggle to change their beliefs. So we now present our proposed research vision, and the different research building blocks we envision are needed to target the previously introduced goal, which was which recommendation algorithms are more prone to spread misinformation and under which circumstances. The proposed research dimensions are presented in this figure, together with how they interrelate with one another. The first one, misinformation problem dimensions, aims to understand what are the different dimensions of the misinformation problem. The second one, analysis of recommendation algorithms, refers to the need of conducting in-depth investigations of the different existing recommendation algorithms and how their internal mechanisms may improve or worsen the spread of misinformation. The third one, human-centered evaluation, refers to the need of modifying existing evaluation methods and metrics and maybe promoting some degree of dissimilarity and cognitive dissonance that could help users to break their filter bubbles. The fourth one, adaptation, modification, and vigilance, refers to the investigation of the different ways in which existing algorithms could be modified to counter their misinformation recommendation behavior. As we can see in the figure, the four research dimensions closely interrelate with each other. The inner circle touches the first three research dimensions, which encapsulate the first part of our investigation, whereas the outer circle includes the fourth dimension. The arrows in and out of these dimensions also indicate how they influence one another. Now we'll provide more details about each of these dimensions. So as I mentioned before, and I think also Barbara mentioned in her keynote, misinformation is a problem with multiple dimensions, at least human, sociological, and technological, among others. Moreover, we consider the following dimensions very important in the intersection between recommendation and misinformation. Content is a key dimension to be considered in the creation and adaptation of recommendations. In our proposed vision, we consider the items to be recommended are online news. This news can be present in various forms: newspaper articles, blog posts, social media posts, etc. And they may discuss a wide range of topics: health, sports, elections, etc. They also include different formats, such as text, images, or videos. Also, the framing of the articles and their origins or the time they are posted should be considered. Users are also important and obviously critical at how recommendation algorithms work. There are previous works that studied the effect of motivations, personalities, and emotions of the users and their effect on misinformation, as well as their susceptibility. For example, there is a difference in behavior between extroverts and introverts, or even with people with higher anxiety levels. Regarding the platform and network features, it is clear that platforms that distribute online information are designed differently and may facilitate the spread of misinformation in different ways. Some examples of different social networks include the ability to vote, for instance in Reddit, express emotions for content, like in Facebook, or content limitations, with Twitter and its 280 character limitation. There are other dimensions of the misinformation problem that may affect the development of recommendation algorithms, such as the ethics of information, having privacy, censorship, or cultural differences, the presence of malicious actors, such as bots, or the presence of checked facts in the information space. So let us now discuss the recommendation dimension. To the best of our knowledge, the current state of the art on recommender systems does not answer whether, how, and which algorithms tend to spread misinformation. Connections with current hot areas can be made, such as the popularity-diversity trade-off, the popularity bias of correlative filtering recommenders, or the portfolio effect and content over-specialization of content-based recommenders. However, no specific response to this problem has been provided. Because of this, we want to focus on the following aspects of the area. First, the families of algorithms, either collaborative filtering or content-based, while also considering hybrid approaches that have proved to be very effective in news recommendation. We should take into account that CF methods do not consider information about items in general, while content-based do. So we expect a different behavior with respect to these two families. Moreover, it is also very important to study how to define the user and item profiles. Multiple representations could be considered, and it is not obvious how each representation may influence their tendency to spread misinformative items. The third dimension is about a human-centered evaluation. Traditionally, relevancy has been considered as the primary dimension to determine the quality of recommendations. we hypothesize that relevance and metrics that target user satisfaction may not be the most effective ones when aiming to reduce the impact and spread of misinformation. Based on psychological and social science research, we believe metrics should account for cognitive dissonance promoted by the algorithms, together with balanced measurements between user satisfaction and user discomfort, if we really want to assess misperceptions. A very important aspect to be able to evaluate this type of research is the availability of datasets that include, at the same time, user profiles and items with labels regarding their misinformation nature or credibility. In this slide, we include two examples of datasets focused on identifying which items are reliable, but these lack any user profile or ratings. On the other hand, datasets from the recommender systems community, such as Newsreel, do not include information about the item credibility. Hence, a possibility that we are actually working on it would be to somehow link these datasets, aiming to find a large coverage of label items and profiles. However, we believe this might be too difficult to achieve. Apart from that, there is another important, almost philosophical question we should be able to answer. How can we measure when the task has been successfully addressed? Right now, recommender systems are expected to provide users with items that are novel, diverse, and relevant at the same time. However, in this work, some of these dimensions will need to be traded in favor of out-of-the-bubble content, while still being relevant and at least related to previous content interacted by the user. So finally, the fourth and last research dimension we envision in our work is adaptation, modification, and vigilance. Since combating misinformation is a complex task, we believe that the adaptation of existing algorithms to counter misinformation spread should build on existing social science and psychology theories. Some examples from the literature show that simply presenting people with corrective information is likely going to fail in changing their beliefs or opinions. In fact, it may even reinforce those opinions. Some strategies that have turned out to be effective in correcting misperceptions include providing an explanation rather than a simple refute, exposing users to related but disconforming stories, or revealing similarities with the opposing group. In this context, we propose some ideas to adapt the existing algorithms based on the presented theories. Besides working on explanations, recommendations should not be solely based on reinforcing similarity, but on introducing small degrees of opposing views or content from opposing groups, so similarities with those groups are also highlighted. Also related to the similarity concept, it is important to consider dissimilarity in content in order to provide divergent views, if possible, from similar users, since this has been proved to be helpful correcting misperceptions. As a last step, we should pay attention to the dynamics of such a modified system, controlling any bias that may be produced because of the adapted algorithms. And of course, be careful with any side effects, as in the examples presented before for Twitter and Facebook. To conclude, let's summarize our project. Breaking the cycle that occurs when misinforming news break and are spread through social and digital platforms is paramount. One of the key components of this problem, we believe, are the recommendation algorithms, which feed and reinforce such cycle. However, in this project, we want to study if recommender systems can be part of the solution and not only part of the problem. For this, we want to understand how the internal mechanisms of recommendation algorithms reinforce, or not, the problem of misinformation, and also how such mechanisms could be adapted to counter it. As we presented before, our main hypothesis is that these potential adaptations should be built on existing social science and psychology theories. Before finishing, I want to share with you our current status to give you an idea of the challenges we have already encountered and hopefully to receive useful feedback from you. So we have decided to start with a dataset with news items labeled, provided by Pointer. The Pointer Institute is specialized in journalism, and its focus is on ethics and fact-checking. As you can see in the image, they collect news items from different sources and their corresponding fact-checked result, either if the information is true or false. Based on this dataset, we were able to get the Twitter users that posted about the news item, which we use as the initial step to get enough users and preferences to train the recommenders on. However, we are facing several issues. First, how many users are really sharing a specific item? From the dataset, we have one user. We are using the retweets, of course, but we need to be careful since a retweet does not always mean the same thing. You can either support or even joke about a previous tweet, and in this case, a misinformative news item. And this is especially true if we allow the quote retweet types. Second, once we have collected a set of users, those posting these news items, those that retweeted them, and maybe some followers of these users, how many items do these users really contain? For this, you need to recall that we only have information about items in the Pointer dataset. So the target items is not so large. We can extend this definition to any URL. So we can at least consider any tweet with a URL, but this would create other problems, as I will show later. In any case, standard tweets with no link are probably not interesting for us. We are also working on using alternative datasets to reduce the sparsity, but this also brings other problems, since each dataset may be specialized in a different topic. For instance, the Pointer one is focused on COVID, or in different periods of time. And third, when building the models and the user and item profiles, what would be a reasonable or realistic ratio between known and unknown items regarding their misinformation? We assume that in the real world, at some point there will be news items that remains unclassified, so we are fine with that. But we do not think it makes sense to only consider the classified items. But what would be a good enough ratio for this experiment, since we expect the outcome of the results to depend on this ratio? Obviously, most of these questions would be unnecessary if there is already a dataset with all this information. But unless you tell me otherwise, I'm afraid there is not such a dataset. The next step, once we have all the data, would be to run the recommenders. We still have not started this step, but we have already some expected problems or challenges, mostly related to the sparsity or biases, which would depend on the quality of the data derived in the previous step. So this is it. Thank you very much for your attention. And as I said at the beginning, this is an ongoing work that we just started. So we are more than welcome to receive your suggestions and feedback about missing works or data sets we should take into account, apart from any other question you may have, of course.
Thank you, Alejandro, for your talk. Let's see if I see some hands rising here in Zoom. Please, if you can send your question through the QI platform, Voiva. I was wondering about, you mentioned that you will evaluate different types of recommendation algorithms. Like if you are assuming that you have an idea about the difference between collaborative filters and content-based, and if they will have different effects in the spread of misinformation, I assume.
Yes, absolutely. That's the first thing we want to confirm. We expect that CF algorithms will be tailored to popular items, and then it will depend if these misinformative items are popular or not in our data. So we assume we will need to do some simulations where the misinformative items are popular, sometimes they are not so popular, like to actually simulate different situations of the network. On the other hand, the content-based, it's a very broad family, so it will depend on how we actually define the content. If
And
we also,
similarity problem.
if we also
Yes.
consider that the recommender knows if an item is misinformative, then the content-based methods will be in a great advantage with respect to the CF method. So we really want to play with all that, all those variables.
Okay. We have a couple of questions in the QA. Should we deal misinformation differently on topics with scientific consensus than on topics without them?
Yeah, well, that's a very good point.
Yes.
I guess.
Also, agreed. Opposing views may be counterproductive if you already believe in human-made climate change, for instance.
Yeah, so like there is, so there the definition is obviously not symmetric. Like if someone has shown that tweets about the informative items, you shouldn't show the misinformative items. That's obvious. I think that question is very relevant, but probably is more related to how you should detect the news items. At least right now for me, we expect to have that information already labeled in the dataset. And the question, at least the first question we want to address is actually, so like analyzing how the algorithms spread, if at all, these misinformative items. Then the next question is, okay, if they spread these misinformative items a lot, maybe you should add some rules based on these labels or something like that.
Yes, and about that, when you introduce some measures for controlling the speed of propagation of misinformation, maybe we have a limit with the freedom of speech, right?
Yeah.
So
yeah.
what do you think about that, about the ethical question implications that when you said we adapt an algorithm, a recommended algorithm for doing this?
Yes, well, right now the recommendation algorithms are already limiting the items we interact with. I mean, both for good and for bad. So there is a huge number of news items or posts or whatever. And if we are using a recommender system, either we know it or not, we already have a filtered view of the information space. So but this is obviously a very good question. How you can bias this information depending on how you modify the recommender system. And this will be in our last part, the vigilance part, where we plan to check whether we are repeating the same problems or we are actually improving the user experience.
Okay. We have another question from Martha. Thank you for your talk. And I didn't quite get the part of the last slide about the ratio. Is that the existing ratio or the target ratio?
Yes, yeah, I explained that very quickly. The thing is, in the pointer dataset or in most of these datasets, we will have most of the data will be focused on misinformative items, so they will not be reliable. So the question we are wondering is, okay, what is an item for us? It's a tweet, but if the tweet is just like a text without a link, then that item will never be, or in few occasions will be shared by other users. So we limit ourselves to news items. And the thing is, okay, the news items that are true are probably not in this dataset. So that question, that issue about the ratio is how many truth items and false items should we consider, at least at the beginning, in our experiments? Should we assume that they will be 50-50, or that the users will be exposed to 90% of truth items and 10% of false items, since we think that we will have to manually complement all this data set with actual news items that are not part of the labeled false misinformative items.
Okay, have another question here from Max. You said that offering educational content is not enough to get people out of the bubble. Can you elaborate what alternatives you see?
Yes, well, I mentioned some of those. What the psychology theorists tell us is that if you only show the corrective information, people will not necessarily change their mind. So some ideas we took from these theories is that you should show similar stories, but with a different idea, or trying to bring the opposing group closer to the person, like trying to emphasize the similarities with the opposing group. In that way, the person will be more open to believe whatever that other group has written or thinks about. So those are some ideas. That's why we mentioned that some possibilities to change the recommender systems are working on the dissimilarity or dissimilarity or similar users.
Okay, just a last question very quickly because we are kind of late.
Yes.
There are some times where misinformation are considered as an advantage.
Well, maybe to improve the discussion or to not always think that the same, so just that there is only one opinion. Maybe like to get the person out of the filter bubble. Okay. Yeah, that could be it. But
in general, had a negative connotation.
Yeah.
Okay, thank you very much, Alejandro.
Okay,
anyway, you can continue the discussion in the Q&A about this. Thank you.
Thank you for the question. Thank you.
Then we will continue with Alireza, which is from the QL University, and his work is making session-based news recommenders diversity aware. Alireza?
Yeah. Okay, can you see my screen?
Sorry. Yes, you can.
Okay, thank you. So my name is Alireza Gharayrehi from Leuven, Belgium. And today I want to present our work on making session-based news recommenders diversity aware. So this is the outline of my paper. So I start with news recommendation, and then I will talk about a little bit about session-based recommender system, and then diversity in news. Then I will talk about diversity-aware session-based recommender system, and then the results and discussion, and finally with some future directions. So normally in news aggregator websites, we have some characteristics for recommenders that we should consider. So we normally have anonymous users, which we call them sessions in this setting. And for this session, we have no information about the demographic information, and also we don't have this long history of logs. Then we also have a very dynamic item set, which means that item set is shifting really fast based on time. And then we have sequential information, and we also have some issues like filter bubble phenomenon, also redundancy in recommendations. So session-based recommenders is a task of predicting next item given a sequence of information or sequence of items in the current session. So session-based recommenders normally use the sequential information in the current session or the active session to predict next ones. And normally we use the previous sessions that we have in the history to do these predictions. According to recent comprehensive evaluations by the papers that I just listed here, simple baselines such as Kainan-based methods have better or at least competitive performance compared to complex deep neural network-based session-based recommenders. And on the other hand, these complex deep neural network-based session-based recommenders are computationally much more expensive compared to the simple session-based recommender systems. Also include some papers from RecSys 2020, so which means that this argument is still valid, that these simple methods like KNN-based has a competitive performance. To give you an idea how it looks like, so as you can see in this table that shows the performance of the baseline session-based recommenders on a music data set. So these simple methods like skNN and also sequential mining has a really good performance compared to like these deep neural network-based baselines like GRU4Rec and NARM and SRGNN, as you can see based on the accuracy. Also from the runtime perspective, as you can see, they're really cheap compared to these deep neural network-based approaches. So we focused here on this simple method, session-based continuous neighbor method, which is a memory-based method that uses all of the items of the current session to find the continuous neighbor sessions. So here, as you can see, if you want to actually calculate the score for a candidate item and for the current session or the active session, you first find some neighbors, and then based on these neighbors, we can calculate the score based on the similarity of the neighbor session with the current session. Okay, what about the diversity? So we normally use item data to boost diversity recommendation. And a common measure to actually measure the diversity is intralist diversity. It's a simple method. And it's just the average distance between pairs of items in the recommendation list, as you can see in this formula. And this distance function between two items, here IOJ, it depends on the type of content representation that we have in our problem. For example, if we have tags, or for example, TF-IDF vectors, we can use, for example, cosine similarity, or if we have like a hierarchy of features, then we should use other kind of distance functions. This is a really simple example of how we can actually calculate the diversity. So if we have a list of movies in the recommendation list that all belongs to action genre, then the genre diversity would be 0. But if we have like a list of movies in the recommendation list that belongs to different or several genres, then we have a better diversity, at least from the perspective of genre. And what about diversity in news? In news recommendation, it's important to address the above phenomenon that you, I think, already know what is that based on the previous presentations. Also the redundancy of the recommendations, which means that we receive similar content, but in terms of different format maybe. And this diversification can be based on several features. So it can be based on text of the article. So it could be based on title, TLDR, or body of the article. It can be based on tags, name entities, even emotion, polarity of the articles, that I think we also have this in our previous presentations. Also the embeddings, which is like can be kind of a combination of all previous bullets. So how we can actually make this skNN diversity aware? So as you can see here, we can add 2 additional components to the previous formula. So we have weight of neighbors and weight of candidates. That I will explain them in more detail next slide. So for the weight of neighbors, we give higher weights for neighbors with higher diversity. So we expect that if we have a neighbor which is more diverse, and if we use that neighbor in a recommendation, we will receive more diverse recommendations. Another scenario is to give higher weight for candidate item with more content dissimilarity with current session. To actually evaluate this approach, we used 3 data sets. So the first data set is a Rulata, which is related to a Flemish media group, and it actually generates Dutch and French news, and then the representation in this data set is content embedding. And then we also use global.com data set, which is I think, a media group in Brazil, and actually the news are in Portuguese, and again, we use content embedding. And the third one is Adressa, which is a Norwegian website, and then we use tags, multi-hot encoding for representation that we need for diversification. And here's a result. So we have here SKNN, the original method, and then the candidate scenario, the diverse neighbor scenario, and the combination of those. So we actually evaluate based on 3 measures: precision, diversity, or intra-list diversity, and also rank and relevance sensitive diversity. And then, as you can see, for the first data set, adding these scenarios, so decrease a little bit of accuracy, but it gives us higher diversity. And as you can see in the third column, which is rank and relevance sensitive diversity, which to some extent show us how we can, is it possible to have a balance between precision and diversity. As you can see, we can somehow improve this measure, which means that we have a little bit of balance in this data set. For the next data set, global.com, so again, we have the same actually result. So we can improve diversity, but with the cost of reduced accuracy. But again, this third measure is increasing. But an interesting thing here is that for this scenario, SKNN under 1D, or these diverse neighbors, we can actually improve diversity without decreasing the accuracy, and it's, I think, an interesting result. And also the same thing for the Adressa dataset. And just an example how it works for the recommendation. So we compare the number of unique tags in the top 20 recommendation in SKNN and diversity-aware SKNN. And then we observe that in SKNN recommendation for a specific user, we receive 25 unique tags in the list of recommendation. And for diversity-aware SKNN, it actually contains 43 unique tags. And what are the main conclusions that we have here? The diversity-aware model offers a wider range of content to the user. And then diversification doesn't necessarily come with accuracy loss, or at least high accuracy loss. And some direction for future extensions. So we want to make other simple baselines such as AR or association rule mining, sequential rule mining, and so on, diversity aware. And we want to do that because, as I already mentioned, based on multiple studies, these simple methods are quite good in performance, and they are super cheap. So we can actually use these arguments here. And then we want to perform a user study to assess whether the diversification approach increases the perceived diversity per user. And then we want to also see which feature is the most important choice for diversification, because as you may remember, we actually have a representation for the articles. So the representation is the tool that we can use for diversification. So we can use the title of the articles as a means of diversification. We can use the text, we can use name entities in the articles, we can use the emotions. For example, we can have bad news, good news, neutral news, so we can have a range of emotion in the recommendation list, and so on. So we want to see which feature is the most important one for diversification in this user study. And then, if it's possible, we also want to address this redundancy issue. It's somehow related or correlated with this filter bubble, but it could be also has its special or unique problem when we receive really similar articles recommendation that they are really actually reporting the same event or same content. Okay, that was my last slide, and time for a question.
Okay, thank you very much. I think maybe just a quick question because we are already late. It caught my attention that the data sets were in Norwegian and Portuguese. And how was your experience working with these languages?
So we had here 3 data sets. So the Norwegian
and Dutch and French. Yeah. You didn't analyze the text, or just?
We didn't actually analyze the text because here I only use tags multi-hot encoding. because I think they actually provide two versions of the dataset, the light version and the complete version. I use the light version, but I think we can easily analyze the text because we have this transfer learning, and we can use some so it's based on like the text and the word-to-vec, for example, or the BERT model to analyze the text of that and then produce this or generate these embeddings. It's not something that we can actually stop us, I think.
Okay, and you are thinking about some evaluations with users on an online evaluation, because probably you're testing against their sessions that already took place and the users were unaware of some of the items.
Yeah, so it's a session based, so we normally don't have this concept of a user. It's like an anonymous user, so it's just one session. So yeah, we want to actually try to study it using a user study, but right now it's just somehow want to see whether we can have this in a session. So when you have like an open session that you interact with some limited number of items, we want to see if we can diversify the recommendation in next item prediction. So just for the active session and not for the like identified user.
Okay. Well, thank you very much for your presentation. So we will do an hour break now. I will just to remind you that we will start the second part of the workshop with our second invited talk by Martha Larsson. So please be on time for this talk that will be also very interesting. So see you all in a while. Thanks.
Start.
Okay. Hello, everybody. So I'm going to be talking about moderation meets recommendation and giving some perspectives on the role of policies in harm-aware recommender systems. Just let me put my earphone in so you can hear me a bit better. Okay, so I'm going to actually start out by telling you my take-home message. So basically, when we're talking about harm-aware recommender systems, e-commerce and social media are actually fighting the same fight. At the moment, there's not too much awareness of this, but I think it's something that we need to keep in mind. And my second take-home message is that moving forward, recommendation and moderation should work hand in hand. So let's start out and talk about moderation. Definition. Moderation is the adjudication of content on the basis of policy. Okay, so what does this mean? We're familiar with policy, for example, as expressed through the Facebook guidelines. So here's an example that's derived from Facebook community standards. Do not post threats that could lead to death or other forms of high severity violence targeting people or places where threat is defined as any of the following. Okay, and then it lists what is considered to be a threat according to the Facebook guidelines and Facebook policy. Moderation then is this adjudication process, which means that content is judged according to this policy. And policy is interesting because it's actually the language that we use to communicate with each other in order to reach consensus on what constitutes a harm-aware recommender system. And I think it's important to pause for a moment and think about this. First of all, I'd like to relate it back to what Alejandro said in his talk before the break. He was asking, like, how can we evaluate harm-aware recommender systems? And I think there we have to talk about policy, because policy is the natural language formulation of what recommender systems should and should not do that we can agree on. The other thing I want to reference back is Barbara in her opening keynote was talking about framing the problem of misinformation, disinformation, harm. We shouldn't frame this problem as a technological problem. So Barbara, I hope I'm quoting you correctly here. And moderation is one thing that shows us that, okay, it's not, because moderation is carried out by people. So those couple of small links to what we've seen in the workshop. So basically, Facebook has taken down QAnon groups on the basis of a new policy against potential violence. QAnon, we know, is a conspiracy theory associated with violence. It was discussed in the opening keynote of the RecSys conference by Filippo Menser already, so I assume that you know what it is. And what's quite curious is that this article states that QAnon has sold merchandise on Facebook, including hats, t-shirts, banners, partly through Facebook ads. Okay, so they're taking these down, and this is our bridge actually to my first take-home message, was about e-commerce. So here is an example from an e-commerce platform where QAnon stickers are being sold. So you can buy these stickers. They're actually getting a 5-star rating here, and you can put them all over the place here, like on the back of your car is a suggested use. And this is basically a real-world retweet of this conspiracy theory. Okay, did we find this on Facebook? No, we found this on an e-commerce platform being sold by a third-party merchant. Okay, so this is a phenomenon of the spread of disinformation in e-commerce, and we need not to turn a blind eye to this. Now, that's not the only example. Let's see, Amazon has applied its policy to remove sexist, racist t-shirts, which appeared when Kamala Harris was selected to be the VP candidate running with Biden in the US. And so we see that basically calls to violence and hate speech are spread by social media, but they're also spread by items sold on e-commerce platforms. Now, what are the challenges of moderation? So both in e-commerce and social media, we see we have quickly changing content, quickly changing policies, and we have subtle judgments that are necessary. Some examples of subtle judgments. So here's a description of an item being sold on an e-commerce platform. We see that it is a racist description because it refers to this underwear as skin-colored, implying that there is only one color of skin, which is clearly racist in its in its implications here. So, but it's a subtle judgment. We can't just say that everything that mentions skin color should be off the platform. Rather, here's another example where we see that the word skin color refers to a set of colored pencils, and we see the full palette of human skin colors here. So these kinds of subtle judgments are what necessitate human moderation. Okay, so this is just one example of the dimensions of the subtlety. So this has us arrive at a question, namely, can automatic classifiers be steered by human moderators to enforce platform policy? Okay, can we actually get a classifier that can be then steered to make these subtle judgments according to policy? So that's what I'd like to look at with you a little bit further today. However, first, let me say something about moderation meets recommendation before we start talking about moderator steering classifiers. So why should recommender systems researchers care about moderation? So why am I standing here at RecSys talking to you about moderation? The most obvious answer, good old GIGO. A recommender algorithm needs a collection that is free of harmful items in order to be harm-free. But also, I would like to urge you to consider that a recommender system is a system. It's not just an algorithm. And our research on recommender systems includes users. And it should also include this entire ecosystem. It should include also moderators. So we don't want to make this artificial distinction and leave the moderators out of our focus of research. And we see that historically, conventionally, with social media platforms, there has been a problem of distance between moderators and the platform itself. Here we see a case of Facebook being sued because of a promotion of a post that urged armed action. If you have followed recent events in the US and know about what happened in Kenosha, okay, and what's happening here, we see a quote from this article from Zuckerberg. We see the distance being made, right? The contractors, the reviewers who did the initial complaints, the contractors, the reviewers who the initial complaint complaints were funneled to didn't basically pick up on this. Okay, so there's the distance there. We see that the moderators who are typically at these large platform companies, contractors, they're being blamed. So we want to bring moderators into our scope, basically, of inquiry. That's what I'm arguing for here. So now you can say, hey, but what does this have to do with ranking? What does this have to do with a recommender system? Because aren't we just making this binary decision, yes, no, throw it off the platform or not? There we can come back to the realization of enforcing policy. It's not always going to be a binary decision. These platforms need to downrank as well as eliminate things, and they do that. So if we're going to evaluate a successful downranking, it also has to be evaluated with respect to a moderator and also with respect to a policy, because this is how, of course, as I say in the beginning, policy guidelines, the natural language statements about what the recommender system should do that we use to communicate. Okay, so basically, those are the reasons why recommender systems researchers should care about moderation. But then you can say, well, how concretely are we going to do this? What do you mean? How do you unpack this vision that you're talking about? And here, I just want to briefly mention a case study that we carried out together with the largest e-commerce company here in the Netherlands. And if we have a moment, I'd like to ask Justine Winkler to turn on her camera and wave. So this case study was her master thesis work, basically done in conjunction with the company. I don't know if that's technically possible for her to do that, or if she does it, if I'll even see it. Maybe not. So anyway, Justine, if she managed to wave to you or not, is in the audience here, and I'm going to be just discussing her work briefly in order to give you an idea about how this union of moderation and recommendation could possibly work. Remember, our question is, can automatic classifiers be steered by human moderators to enforce platform policy? And here we look at data programming, which is a new paradigm used for creating training data on the basis of rules. So here's an example of a rule that you can have a look at. Because of the restrictions of the company, and I think for quite obvious reasons, we're not allowed to talk to you about what the exact rules are. So I need to talk to you about this at a very high level, but I think it's enough for you to understand what's happening here and what we discovered in the case study. So the case study is looking at whether moderators can steer the training data that is used to train classifiers by changing the rules based on their knowledge of policy. So we're translating the human subtlety of judgments into training data. And if they can steer the training data, then they can steer the classifier. Okay, so how's this gonna work? So we use a paradigm called data programming that has been recently developed. Here you see the moderator. I'm gonna be focusing on 3 parts here briefly. So here's the rules that the moderator is creating on the basis of policy. This goes to create a labeled matrix. A generative model is applied. We end up with this training data. And what our work here focuses on is these inspiration sets. So we ask that if we can, from this pipeline, draw data that we can feed back to the moderators in order to help them improve their rules, in order to help them steer. So we have 3 inspiration sets. These inspiration sets are sets of data that inspire moderators to create new rules relevant for a given policy. We have 3 sets. I think just the relevant thing to get here is that the first 2 are unsupervised, meaning that we don't need gold labels to create them, and the third one is supervised. And we are doing this in a very fast pace. The moderators only have 30 minutes to update their rules. So let's see what happens. We look at the ability of the rules to cover the data, and we do that for 6 different policies. I'm going to zoom in here on the policy against single-use plastic on the platform that we were studying, and we see that here's the initial set of rules, that many of the data points have absolutely 0 coverage, and the greener and the darker it gets, the better the rules are doing at covering the data, which means that we'll have a better generative model and a better data set, we hope. So you can see that here set 1, which is an unsupervised set, did have a good impact because the bar gets greener. So how does that translate into an F2 score judging the quality of the label data. We see from the initial data to the set 1 inspired label data, we do get a nice jump in improvement. Now remember, this is not the performance of the classifier. We're talking about the quality of label data, which would then go through other things in order to create the classifier. And we've used a classifier that can also leverage weak labels. So what we see is the inspiration sets do usually lead to higher quality labeled data. Okay, this jump here. And we also see that this higher coverage, the better the rules cover the data, which we can look at without any supervision at all, that leads to better coverage data. But when we look at the full chart, it's not always. So it can actually be that new rules can hurt the performance. So the inspiration needs to be done very carefully. And here we see a case where inspiration didn't help at all. So in general, we see that this approach in our case study turned out to be promising. In that very short time, the feedback could happen. But in general, I think the main thing to look at here is that we actually don't need gold label data in order to inspire our moderators to make their rules that get closer to the policy, which is super cool, which is also helps for the hope for efficient steering. Okay, so take home message, I already told you, e-commerce and social media are fighting the same fight. And moving forward, recommendation and moderation should work in hand. So our case study is showing potential for combining algorithms and moderation more tightly than we do. So, you know, we build the data programming into the classification part of the pipeline, but it could be built also into some other part of the recommender system pipeline. Finally, I'd like to thank Justine, obviously, but also thank you to all the people at Bowl.com, which is the e-commerce company that we work together with that made this, this work possible. And finally, here's a list of references, data programming and moderation. And if you're interested in learning more about moderation, I suggest these 2 books here at the bottom. Thank you very much.
Thank you, Marta, for your talk. We have a few questions for you. First, which actions can be taken by the RecSys system for moderating? Or how do you plan to make the moderations? You mean, would content changes be suggested, or what do you think would be the more appropriate approach to follow? So,
so if we're talking about moderating the ranking, you need to set up a policy for what the ranking would look like, and then you can evaluate the ranking according to this policy. And last year at a workshop, we had a short vision paper about how exactly you could actually direct your recommender to give you a smaller number of ranked lists so that you could possibly apply this more efficiently. Okay, but the link up is that whatever the output of the recommender is, there needs to be a policy, and moderation then checks to see whether the output is applying to a policy. In this, and using data programming, you can get this automation. It's hard because I don't know if that person answered the question. Okay, if that was a satisfactory answer or not for the person, but I'll look in the chat after. Actually, I can see it already here.
Okay, and do you think that this approach can be applied in a large-scale scenario?
Yes, that's the point.
We could do it on Amazon, for example.
Yeah, this we're doing it. The case study was carried out together with the largest e-commerce company in the Netherlands. And maybe just point out is that the challenge is not the scale here. The scale is taken care of by the data programming, but the speed at which the changes happen. So you know, you're looking at third-party merchants. they can also be adversarial. So they're adapting to whatever moderation that you're doing. So you need to go incredibly fast in order to keep up with their ways of circumventing and, you know, the rules.
Great. And the policies are created by the company or suggested by moderators or by users?
This is a key question. So what happens, and also I think that these books really reflect on that, is that the platforms create the policy, but they're influenced, for example, when there's a scandal in the press, then they adapt. Like you saw what I was showing about Facebook adapting to the issue with QAnon. Okay, so they're adapting the policy. Historically, the moderators who know an awful lot about what's happening on the platforms, they do not contribute directly to the policy because of being contractors and not being employees of the platform. So there's one disconnect there that has been a problem. But under ideal circumstances, the public would be able to feed back and influence this policy because, as I said at the beginning, it's expressed in natural language. So you don't need to know any computer code. You can express how you think the policy should change according to what your understanding is of a harm-aware recommender system as a user. And something like this data programming pipeline, together with the moderators, can translate that into actual system behavior.
Okay, so we don't have time for more questions. Please remember that you can continue the discussion in the QA section. Thank you, Marta, for your talk. So for our next talk, we have a Bilal Ghanem, who is a PhD student at PRHLT Research Center, Universidad Politécnica de Valencia, Spain. He's currently working on the detection of fake news and suspicious users on social media. Welcome, Bilal.
Thank you so much for your introduction. Just let me share the screen. Can you see my screen?
Yes.
Okay. Thank you so much. As you mentioned, I'm Bilal Ghanem from the Technical University of Valencia, PhD student. And I'm working in general and generally in misinformation or false information. And in this work, I'm going to present our paper, which is entitled Text Trolls, Identifying Trolls in Twitter with Textual and Effective Features. In the beginning, I will introduce the research problem that we worked on. Then I will show you how we built our dataset and our proposed textual feature. Then I will present the experiment, analysis, and then I will conclude my talk. So as most of you know that during the US election in 2016, the Democratic Party that headed by Hillary Clinton claimed that there were a lot of fake news or rumors against her party, attacking her from suspicious accounts on Twitter. And in that moment, the Conservative Party didn't say anything or didn't release anything about this problem. But after the elections, Twitter detected or released that they detected a Twitter claim that originated from Russia, and they were attacking the Democratic Party and at the same time like supporting the Conservative one. And for that, they released a dataset of these accounts that they were spreading false news about or rumors on Twitter. So I don't want to talk a lot about politics, and I'll tell you what is troll, or the thing that I mentioned as a suspicious account. A troll is someone who's posting offensive or divisive remarks on platforms such as Twitter and Instagram, for instance. And in this work, what we are trying to do is that to build a classification task where we have these era trolls accounts. I said era because this is how they call it, and they claim that these accounts originated from like an organization that's called Russian Internet Research Agency. So we are trying to build a classification task to classify these era accounts from regular or real users in Twitter. So for that, we build our dataset, and then we use topic and profiling based features to detect these era accounts. These are our research questions. In the beginning, we want to know, can we detect error trolls from only a textual perspective? The second research question is that, does the topic information improve detection performance? And the last one, how error campaign utilize the emotion to affect the public? So in the beginning, for our dataset, to model the detection of the error trolls, we considered a large dataset of both regular or legitimate users and error trolls accounts. For the error trolls account, as I mentioned, that we used the dataset that was released by Twitter, and we applied some kind of pre-processing to remove non-English tweets and retweets, and I will mention why in the next slide. And for the regular accounts, we sampled a large amount of real or let's say legitimate users that they were spreading, tweeting tweets between the 1st of August and the 31st of December 2016, which is the period that the elections, or yes, the election was running, or the final period of election was running. For that, yes, I mentioned here that we use users that they post at least 5 tweets in this period, and we use these hashtags, which are Trump, Clinton, election, debate, and so on. So at the end, this is our dataset. We have around 2,000 error trolls account, and for the regular account, we have 94. And each of these accounts or users have n number of tweets that we were tweeting in that period. And these are some of the statistics that we extracted from the dataset. So for our textual features, we use two topic-based and profiling-based features. For the topic-based feature, we use a set of cues or lexical features to know how these features varying across several topics. And for the profiling features, we mainly use native language identification features and stylistic. For the native language identification features, we want to investigate if we are able to detect these Russian, I would call them Russian accounts, from their language or from their writing style of when they write English comparing to a US citizen or a native English speaker. And the other feature, which is stylistic, we want to know if the trolls accounts have a unique stylistic pattern or feature. So for the topic-based feature, the first thing that we have done is that we extracted in topics, and for that we use LDA topic modeling algorithm. We tested different number of topics, and at the end we used 7 after manual checking of the results, and we manually annotated these 7 topics. We annotated them following with this topic: police shooting, Islam and war, Trump, Black people, civil rights, and Hillary and crimes. And as you can notice here, that these topics are like hot topics that were used in that period for the election, that some of them, they were supported by the Conservative Party and the other by the Democratic. After having these topics, we annotated our tweets, each with one of these topics, to know that this tweet, for instance, talk about Black people or about Trump. This is an example for the from our dataset. So this is a word frequency cloud for both topic for Trump topic and here for Hillary, just to show you the differences. And as you can see here, for the most frequent hashtags, we have something like Never Hillary, MAGA, which is Make America Great Again, and so on. For the Hillary one, we have things that they were against Hillary, like WikiLeaks, pro Hillary, and terrorists, and some other words. So, okay, so that was for the topic-based features. For the profiling features, for the native language identification features, we use just to mention that these features, we use them just to take, after taking some intuition of a state-of-the-art approach. So these are like state-of-the-art approach for detecting native language or in the native language identification task. And for that, we use bag of stop words, bag of part-of-speech tag, and bag of syntactic dependency relation. For the stylistic feature, we use features like count of special character, consecutive characters, uppercase ratio, and so on. For our models in the experiments, we use mainly two main models: logistic regression, and the next slide I will present a convolution neural network. Here, for the logistic regression classifier, we model the features in the following, as here in these two equations. For the topic-based feature, since for each user we have n number of tweets, and these n number of tweets, some of them annotated with these tweets annotated with different topics. So for that, for each tweet, for each user, we were looping through each of these topics. And then, for instance, for the first topic, let's say Hillary, we apply the average for the feature that we extracted from these tweets from the same topic, and we concatenated the standard deviation for the features of the topic tweets. And then we concatenate this first vector with the next one, which is for the topic 2, topic 3, and so on until 7. This is for the topic-based feature. For the profiling features, we extract mainly vectors and we concatenate them, the mean and the standard deviation. And since here we don't consider the topic features or the topic information, we don't loop through the topics. Here for the other model, which is a convolution neural network, as you can see in the first part, we apply convolution process, or yes, a convolution process for each of the topics. So we have 7 convolution neural networks, each process one of the topics. Then we apply max pooling, and we concatenate it with the profiling features, in which here we concatenate the native language and the stylistic feature for each of the users. Then we feed them to a dense layer, coordination, and then we have a softmax. So here are the results. I don't want to talk about the baseline since I don't think that I have enough time. But in general, we use state-of-the-art works in this problem, or like well-known bot detection system. So what I want to highlight here is that for the topic information features, so when we run the logistic regression, only the topic-based features, we have 0.78 F1 of only of the positive class, which is the trolls. And for the CNN, considering only the first branch, which is the one of the topic information, we have 0.80. For the next one, which is profiling features, the same thing. For the logistic regression, we have 0.88, and for the CNN, 0.84. And at the end, when we combine both topic-based and profiling-based features, we have 0.91 for the whole feature with the logistic regression and 0.88 for the CNN. Here we tested some other classifier like random forest and the neural network. As you can see, the best performance was by the logistic regression. In the analysis part, as the second question mentioned, which is we want to check if the topic information improves the performance of our classifier. And for that, we use the logistic regression classifier. And for the logistic regression, we use we run it each time with one of our lexical features, once considering the topic information and once without. So the plus is that when we extract, for instance, sentiment each time from each of our topics, and here in the other part, we extract the sentiment from all the tweets without considering topic information. And as you can see here clearly, that considering the topic information feature boosts the performance marginally comparing to discarding the topic info. For the other experiment in the analysis part, same thing here. There are many things that I mentioned, but I would highlight here the main thing, or let's say the thing that we saw that was the most important part, which is for the fear for the fear and the joy emotion. As you can see here, for instance, for the topics that we are supporting the Republican or the Conservative Party, which is Trump, for instance, we have a small amount of fear, but with the for the joy emotion, we have much higher. But for the other topics, like for instance, Black people, which was one of the main prior topic that they were the Democratic Party talking about, we have here a lot of fear emotion, but lower amount of joy emotion. And the same thing for the other topics. Some topics some topics we were not able to find a clear pattern to understand them, like for instance for the civil rights. But in general, this is what we have. This is the main point that we noticed in this experiment. The next thing we have done is that we conducted a statistical significance test using Mann-Whiteley test. And here what we are trying to do is that for each of our features, our feature category, we want to check if the feature has a statistical significant difference comparing to for Eratol's account comparing to the regular users. So the shape of X, arrows Y, and these arrows, they are three main levels for the p-value. So if you have 0.001, we have three arrows, 0.01, two arrows, and 0.05, which is the threshold, one arrow. And here are the results. So I don't know if I want to take one example like harm in the morality feature or in the morality feature category. As we can see here, we have 2.3 of the average value from the trolls accounts, comparing to 0.61, which is much lower than the regular accounts, and so on. Some other patterns, other categories. The next experiment in the analysis, we were trying to rank the topics comparing to with respect to the importance of the topics in the classification task that we have done. And as you can see here, that we have Hillary topics as one of the most important topics. Then we have Black people, civil rights, and so on. Someone could ask how we extract with these importance or ranks for the topics. We just use the feature importance from the logistic regression classifier, and from the then we check the end topic. After getting the feature importance from the logistic regression classifier, we were getting the topic from each of the features, and at the end we applying averaging. So at the end we can see Hillary Clinton features were at the top, then Black people features were at the second level, and so on. And then in the next experiment, we dig into the previous one more deeply, and we were trying to extract for each of the topics that we extracted, the top important features. So for instance, for the police shooting topic, we have an anxiety average, harm average, and an anxiety standard deviation. And as you remember that for each of the topics, we were building the average or the mean and the standard deviation. We were representing the feature using these two, mean and standard deviation. So these were, for instance, the top feature for the police shooting topic. And yes, this was an example. And maybe you can notice other things like here also for the Black people topic, unfairness, standard deviation, anger, and negative sentiment. So yes, this is the second part of the topic importance analysis. And for the conclusion, so as you mentioned, as you noticed that we present two text-based approach to detect social media trolls. And the extracted topics, answering the second question, the extracted topics boosted the performance of the proposed model when coupled with affective and lexical features. We proposed native language identification feature to identify error trolls from their writing style, which showed to be very effective in the classification task that we presented. And for a better understanding of our classification task, we analyzed the error accounts from emotional, linguistic, and thematic perspective, or the topic perspective, to understand more how the features or emotion and or linguistically the two classes, the error accounts and the regular accounts, were different. And as a future work, we would like to integrate an emotion and irony detection module in our system. Why? Because during analyzing the false positive cases in our analysis part, we noticed that there were a lot of tweets that were written in ironic way to offend someone or one of the parties. So we think that integrating irony detection module would improve the performance of our model. So this was my talk. Sorry if I was a little bit quick when I presenting one of the parts of my presentation, but I think now we have 5 questions for 5 minutes. Sorry for the question, so I wasn't in time for the talk. And yes, thank you so much, and I'm happy if anyone has a question.
Okay, thanks Vidal for presentation. We have a few questions for you. First, regarding the topics you selected, you mentioned selecting 7 topics. How did you reach that number of topics? I mean, which criterion or metric or heuristic did you use to choose them?
Well, for this part, we were doing manual checking for the topics. So we were testing like 10, 7, 5, for instance, and then we were taking the top important words in these topics and checking if there were like clear topic for clear orientation in this topic. And yes, just manual checking for the output. And at the end, we found like 7 topics were the best or the most suitable.
Okay, great. And well, when you showed us the data set, it seemed to include users with different distribution statistics, meaning different average of published tweets, different average of followers or followees. Do you think that such differences could have affected or modified the results or have any influence on that?
Well, for this point, this was one of the baselines that I didn't mention them because of the small amount of time that I have. So for instance, I use, since we noticed a clear difference between both classes, we did some experiment for the network features, for instance, for the number of followers and so on, to see if they were able to detect error trolls, and as you can see here, 0. Another thing, someone would claim that the number of tweets from the error trolls accounts were much higher comparing to the regular accounts, since the fact that at that time error trolls accounts were posting a lot of tweets. And for that, we run this experiment, number of tweets, with a naive basic classifier, and we were able just to detect half of the error trolls accounts. So these main baselines, I think they answer your question.
That's great. And we have here one question on the QA. How do you plan to generate the data set for irony detection? And how do you plan to tackle that detection?
Well, I think the now state-of-the-art work or state-of-the-art approach in the task of irony detection has like quite high results. So there were a lot of shared tasks for detecting irony detection, and there were a lot of systems that they're reaching something like 90-something F1. So what we were thinking about is that to take one of the state-of-the-art approach, or the feature of state-of-the-art approach, and then to annotate our tweets, or to use it part of our system to detect these like ironic tweets in our dataset.
Great. And can you elaborate a little bit more regarding the writing style of bots and how they differ from normal users?
Well, which is, sorry, it's me. Yes, here for these features. So here I didn't mention we did another experiment. it's I didn't add it here in the slide because I didn't have enough time also, but we have done many other experiments in our paper. But after using this feature, we have done the same thing that we did for some of our experiment in the analysis. We use feature importance simply for this feature, and then we compare their importance in the classification. So which one of them were the most important for the classification for the classification task. And the same thing we were trying for the stylistic features. So after extracting them and so on and feeding them to the classifier, we extracted the top important features for both of the classes to see what's the main differences between both classes. We noticed some few things like I don't remember exactly, but something like one of the classes that were using a lot of I or she stop words and so on from the part of speech and so on. And we were trying to match these results that we got with other research work on native language identification to show the differences between a native English speaker with non-native English speaker when they write English text or English text.
Great. And the last question, how emotions were detected?
Sorry? I mean,
how were the emotions detected? Did you use a lexicon or?
Yeah, exactly. Here for the emotions, these features, all of them we use lexical features. For emotion, we use NRC lexicon, it's well known, which is from National Research Center. Yeah, the same thing from the other lexicon. We were trying to use previously proposed lexicon. We were thinking to use like a coherent or full approach to detect our to extract the emotion or the sentiment from our tweets, but then at the end we went with this simple way.
Great. And are you planning to repeat all these analyses over other data sets or other users?
Well, actually, this is
like not considering IRA bots.
Yeah. Actually, yes, as I mentioned, this is really interesting question because the phenomena of trolls, doesn't exist only during the US election. There are many other cases, like for instance in China and Hong Kong. I don't remember something between Ukraine and Russia. For instance, in the Middle East, something between Qatar and the other party was UAE, Saudi Arabia, Egypt. So the problem here in one of the limitations of our approach is that we use these lexical features, and these lexical features, they contain only words in English. So the problem is that using the same approach for other languages, we were not able to do that because we need to represent these these lexicons in other languages. So initially we are not able, but we are trying to use to build like a word embeddings-based model to extract all of these features, and then in that moment we will be able to use the multilingual embeddings and so on to apply our full approach to other languages. We were thinking about that to do like a case study for actually the one of Qatar and Saudi Arabia, UAE, and Egypt case. But yes, this was one of the limitations of our approach.
Okay, looking forward to read that article. Okay, thanks Bilal for your presentation.
Thank you so much for your listening, and thanks for everyone.
Okay, next we have Ridwit Sinan, who is a data scientist at Adult Research. He completed his PhD in 2007 from the Case Western Reserve University. Hi, Ridwit.
Hi, can you hear me? Let me try to share my screen.
Yes.
Okay. Okay, so I will have to restart Zoom because this is the first time I'm trying to share.
No problem.
We would like to label every session like that. So let me talk about some history within the machine learning literature. Machine learning, classical machine learning, makes the assumption that every observation has a label. So the leftmost image here, every point is either a green or a blue. Green point denotes that it is positive, blue point denotes it's negative, and the goal is to find the best separating curve or line or plane between them. Semi-supervised learning, you have some blue points, some green points, but you also have a bunch of points which are not labeled. But there is this class of algorithms called PU learning, where PU stands for positive and unlabeled, where the hope is that we'll be able to learn from a data set in which only a subset of one of the two groups is labeled. And in this case, we assume that a subset of this positive points is labeled, and we would like to still learn from this limited situation. And this obviously is a much lower data requirement that is more likely to be satisfied in many scenarios. So what are some examples of the positive class that we have in mind? Some examples we have in mind and do use is things like buyer session or buyer's sessions. So what this means is that if I go to the website and I make a purchase, I am definitely a human. We make the assumption that no bot will ever buy something on a e-commerce site, and that seems like a pretty reasonable assumption. Or we could have other notions like two-factor authentication. Anybody who has done a two-factor authentication is a human, or anybody who has cleared a CAPTCHA potentially is a human. These are signals that we can use. So the one of the challenges with PU learning approaches is that PU learning approaches take this assumption of selected completely at random, which means that if you have a bunch of points, humans here denoted as circles, you assume that a subset of them, a random subset of them, are labeled and available to you. And this is obviously not a great assumption. If you think about, say, buyers, not every human is equally likely to make a purchase on a e-commerce site. So that's an assumption that breaks down with the standard PU learning approaches. So let's look at some of the technical details of this work. So we have X, which is a feature vector, Y, which is the label. This is a true but unknown label. So Y equal to 1 denotes human, but we do not observe Y. What we do observe is S. S is a sample, S stands for sample, but S equal to 1 denotes that this is a known human. So in our image, the blue points are S equal to 1. And in one of our approaches, we further assume that there is another even smaller subset of known humans called B. We want to learn the classifier probability Y equal to 1 given X, but from the data, we can only learn probability S equal to 1 given X. So the first classifier is the unknown, but what we are interested in. The second classifier is what we can easily learn from the data. And so by using Bayes' theorem, we can show that the classifier we are interested in is essentially a ratio of two classifiers, because by design, this probability S equal to 1 given Y equal to 0 is always 0. Okay, so no bot will be labeled by design. So we are interested in this ratio of two probabilities, and the numerator is easy to learn as we have as is obvious. The denominator is where we have to put in more work. The work by Elkan and Noto shows one way of doing this, and it makes the assumption that the probability that a human will be selected is not a function of the features and is essentially completely at random. And so this is a limitation. So we would like to make two modifications. The first is when we extend the ideas from this paper to marginalize over this additional random variable b. The motivation for this is that the assumption that we are making is less strict than the vanilla model. And so we are still required dropping the X feature from the conditioning, but it is in a smaller subset of the data. And the second assumption, type of model we propose is one where we assume that closeness is in X's helps us generate negative samples. So I have very little time left, so I'll quickly talk about the validation data set. So for the validation data set, what we did was we take this KDD cup data set, which is completely labeled network intrusion data, and then we simulate a PU learning data set by hiding all the negative points as well as a big subset of the positive points. And the way we do that is by systematically hiding these points. So points which look more human are less likely to be hidden than points which look less human. So that's the idea. And what we see is that the proposed approaches, particularly the last one, relaxed assumption model, perform significantly better when there is no randomness. So on this axis, as we are on the left, means that there is no randomness in the, there is no randomness, as in the people who look more human are more likely to be sampled. And as we go to the right, we are in a situation where the sampling completely at random assumption holds. And so you expect Elkin's model to work better, which is what we see. As we see more extreme sampling, we see that our approaches work better. So that's the summary. And we also tested it on some real data, and we found good evidence that we can indeed detect bots. I won't go into the details in the interest of time. Just to summarize, we proposed a PU learning approach to detect human activity, and we deal with the sampling completely at random assumption. And we validate our approach using proprietary and public data sets. And potentially we can try other types of classifiers in the PU setting. We can use PU learning to estimate and improve other types of supervised classifiers. And we would like to study the effect of removing bots on other systems as well. So with that, thank you.
Thank you, Rick, for your presentation. We have a few questions for you. First, how was the dataset labeled?
So I talked about two data sets. The first data set is one where we have this network intrusion data, which is a completely labeled data set that was generated from network intrusion exercises. We take this data set and then we systematically hide labels, right? So we hide the labels for all the bots, and then we also hide the labels for some of the humans. And the way we do it is we introduce a biased sampling scheme. And what I mean by that is, just to give you some more context, we essentially build a classifier on this fully labeled data set. From the classifier, we get the probability of 1 and 0 in this fully labeled data set. We use this probability to cut thresholds. So if you have, say, 50% bots and 50% humans, you have this bimodal distribution on the probabilities. On this probability graph, if we are on the left, we are looking at humans who have a very strong evidence that they are humans. And on the right of that are people who there is some confusion whether they are humans or bots. So we simulate that, artificially simulate a PU learning data set to test and validate our approach.
Okay, in your paper you mentioned about the sessions of Azure or AWS as non-humans. So right. How valid is that assumption? Right,
yeah, so that assumption was never used to learn the model. That assumption was used to provide an outside view, outside validation exercise that we used in our real data set. So in the real data set, what we did was we do not have any labels because we don't really know if a visitor is a human or a bot. But the hypothesis we had was that we saw some traffic from IP addresses that are generated on Azure and AWS, and it's less likely that a human being will launch an AWS machine to navigate to the website of an e-commerce site. And that was the assumption. So we never used that label to learn our model. We just used it to provide outside validation for our real data set.
Okay, great. I think we don't have one more questions. Could you explain a little bit about how the parameters were selected, the topper and mixing parameters?
Sure. So you remember this bimodal distribution I talked about on this fully labeled data set. So when I say topper, it means that I will select the top 5% or 10% or 20% of that bimodal distribution. And by mixing, what we did was we selected the top parameter, but if we do that, we get distributions which are very well separated. We wanted to like add some randomness, some noise to that. So the mixing parameter was a reflection of the noise. So even if at 10% topper, if we mix a lot, we get random sampling. So it satisfies the conditions of Elkan's paper.
Okay, thank you, Ridwick. Okay, for our last talk, we have Ben Salem-Rim, who is a computer engineer specialized in advanced software engineer, master of embedded systems, and PhD student.
Hello.
Hello.
I'm going to start a screenshot. Okay. Okay, just a second. Okay, just a second. And just a second, I cannot see PowerPoint to share it, so. Yeah, just right now. Can you see the presentation right now?
No.
Okay. Okay, let's. Can you see it right now?
Yes, now yes.
Okay. Okay, so, okay, yeah. Okay, so hello everyone. My name is Reem Ben Salem from the University of Montreal.
Sorry to interrupt, we are seeing your presentations page. You should change your display.
Yeah, I'm just not sure. Can you see it right now? Even
yes.
Right now, can you see the presenter page?
You enter the presenter's page, yes.
Yeah, for some reason it keeps, yeah, let's just do it like this. So, so hello everyone. My name is Reem Ben Salem. I'm from the University of Montreal, and I'm going to present our paper entitled A Nudge-Based Recommender System Towards Responsible Online Socializing, which is a joint work with my supervisor, Professor Asma Aimer, and our collaborator, Professor Hisham Haj. So this is an overview of the outline. We're going to start with our motivation. Why do we use a nudge-based approach? And the architecture, detail and evaluation, and finally conclusion and future work. So starting with the motivation. So there's no doubt that in today's world, the use of IT is everywhere. However, with that comes a challenge, which is basically every danger that comes, such as data breaches, records that are being exposed. So in this figure, we can see the exposed records and data breaches over the last decades, which have grown exponentially and are now in the billions. So we present these statistics in order to get to our point, which is 64% of people have never checked if their data is compromised. 56% of people do not even know what steps to take, even if they do realize that their data is actually compromised. Yeah, and 65% of all attacks, they use spear phishing as the primary infection vector. So this allows me to smoothly transition to our point that there are that we basically need to focus on the user and not just like the systems. So we've got two categories of potential victims, let's say, so people who are unaware, who disclose pieces of information and don't even realize what or the value of what they're disclosing. People often say like, I've got nothing to hide, and they share everything. And there's also the other category, which are people who do careless or hasty disclosure, let's say, who do have the actual knowledge, who know the consequences, but due to a lapse of judgment, they sometimes make the careless decision to, for example, share a piece of information. So efforts do exist in order to mitigate these dangers and to actually raise people's awareness and users online, such as campaigns and government-funded programs and ads that are pretty much everywhere, where they educate people on the do's and the don'ts, as well as the how-to and repercussions of actions where these users to actually make these decisions and disclose these informations. So why do we use a nudge-based approach? In order to define this, first of all, we need to define what a nudge is. In fact, a nudge in behavioral science, it's a positive reinforcement that is meant to change a certain behavior towards what is considered to be positive, what is considered by, let's say, society and in general, like it has positive value and positive impact. So in order to achieve these socially desirable outcomes, the concept of nudge exists. Examples of nudges in real life is, for example, this, where in order for people to be aware of, for example, overusing paper tissues, let's say, they have like these maps where people, when they're actually taking paper, it shows the green that's leaving the map, which has a negative impact. Because of the negative framing, it leaves an impact on the user in order to reduce their paper usage. So we've got recommender systems where the goal is to personalize suggestions, and we've got nudges where the goal is to have or to reinforce a certain positive behavior. What we would like is a marriage of the two, where we've got personalized suggestions that are actually aimed towards changing a certain behavior. And in our case, it's a more cybersecurity and privacy-aware behavior. So why do we use personalized nudges in specific? Because, well, users have different reasons for disclosing or for using or for like having certain action, performing a certain action. So for example, someone who shares their photo on, let's say, Instagram in order to gain ads or promotions has different motives and different biases from someone who is sharing their photo just, let's say, to gain friends, or sharing a piece of text to share their experience and like communicate with others. Same for preferences and also background, because people's level of education, their, let's say, country of origin, and all of the things that they've built their entire background highly impacts like their decision, which is why the nudges themselves need to be personalized. So now we move on to the architecture. So we're going to introduce different modules of the architecture one by one. So we've got the user model, where we model the trust that someone has in other people that they share information with, as well as the trust in platforms. So someone might be more likely to share a piece of information on Twitter more than Facebook, for example, as well as privacy preferences, and they reflect how the person assesses their own assets or their own data, valuable private information. The second component is user records, where we keep track of interactions with the user in order to further personalize the system. The next component is the information extraction, which refers to how we analyze the user's input in order to detect, for example, let's say, whether they have disclosed something important or not. Then the next component is domain knowledge, where we keep like information of the phenomenon as a whole, as well as the general like database. So we've got disclosure tendencies amongst users. We've got objective weights that we are going to use later on to have an objective risk assessment. I will further explain that a bit later. And we've got also disclosure rates within users. The system orchestrator serves as a medium between these components. And of course, we've got the recommender system. So when it comes to the interaction between these different components, our aim is, yes, to mitigate the dangers of disclosure while taking into account the user's preferences. But for this study, we used text input. We focus on text information. So this text input is going to be analyzed by the information extraction module. Then a threat vector is going to be produced, which corresponds to the user's input. This threat vector is going to be communicated to the recommender system along with the user model as well, user model because it has like prior information, as well as the domain knowledge and user-specific information and domain knowledge. Then this recommender system is going to recommend personalized nudges to the user based on all of these inputs. The user then has the chance to make actions and provide feedback, or actions we also call them like implicit feedback, because if the user accepts or refuses the nudge, it's an action and it's an implicit feedback that should be reflected on their behavior and in like future recommendations, and explicit feedback as well. That feedback is going to be communicated to the recommender system in order to adapt it further to the specific user. So if we zoom in a bit on the recommender system in specific, we've got three main modules. As we just explained, so the recommender system receives the threat vector and user specific parameters from the system orchestrator, which has been like who is like the system orchestrator is just a medium that communicates this information. Then within the recommender system, the following actions are going to happen. So the threat assessment module is going to produce an objective risk assessment. Then the evaluation module, it's based on the user's preferences. So it's going to provide a subjective risk assessment. And like the entire goal of the recommender system is to provide these nudges. So the personalized nudges module is going to push these nudges to the user that are personalized, and then the user provides feedback, and it goes back to the system and it loops again. So now we're going to move on to details and evaluation. So for the objective risk assessment, it's a weighted function of like the disclosure rate, how much the user has disclosed, multiplied by the importance of what the user has disclosed. So these weights W, they are actually objective for all users. So at this point, we're not personalizing anything except for like the output of the F function, which is corresponding to the user's input. But the weights themselves at this point, they are objective. So we need values for these weights. So we've got the idea to have objective weights, but we need specific values. So in order to do this, we used statistics by TransUnion and Equifax in order to get an idea about the value of personal data on the dark web. So at this point, we make the assumption that the more valuable a piece of data is on the dark web, the more sensitive it is, and the higher its weight should be. So in correspondence with this, we made like these evaluations. So we've got, for example, date of birth, address, social security number, email and password, and so on and so forth. So we've got now these values that we've averaged and all, but we need values that we actually are going to work with without all like the noise and different, let's say different values. So we've got different classes in correspondence with the sensitivity of the data. So we've binned the data into least, low, medium, high, and highest sensitivity. And each class has a representative element. So for example, for least, we've got the representative element that we're going to use for calculations, it's 1.25. For highest, for example, it's 9. So if we move on to these examples of scenarios within the paper, we've got a lot more, but for the sake of this presentation, so we've got, for example, in the first scenario where the user discloses their location via activating the Snapchat map location feature. Location was deemed to be least sensitivity, and its risk value, we're still talking about the objective risk value at this point. So the risk value is 1.25. In the second scenario, for example, the user is not aware of this scam where they're being asked information about their passport, and they respond, so they've revealed information of a high sensitivity that was evaluated as 6.5. And the third scenario, for example, the user has revealed banking credential, which is of highest sensitivity, and the risk value is 9. So now we're done with the objective part. So for the subjective or personalized nudges algorithm, basically each user has a threshold. So the threshold is the user's limit or tolerance to threats. So let's say the lower it is, the more aware the user is. Because, for example, let's say with someone who has a threshold of 2, then the least, let's say 2.1 or 2.2 risk level is going to be trigger the system into notifying them and pushing the nudge. So for this loop is where we determine which nudge exactly, or which piece of data exactly does the user need to be notified of. So at this point, we combine the objective function where we've got the weights, the objective weights, as well as the subjective weights, which are basically the user's preferences. And we try to figure out which pieces of data need to be, let's say, deleted, which pieces of data are going, that the recommender system is going to ask the user to delete in order to mitigate the risk. And in the third instruction here, each time that the user, for example, deletes a piece of information, the objective risk is going to be reduced, of course, because a piece of information has been deleted. So at this point, we're going to present a scenario of all what we've presented up until this point, so the objective and the subjective parameters. So let's say that a user has disclosed their social security number and address, for example. In accordance with the previous tables, the risk is 2.5, which is like the sum of the two. And the user parameters, we're supposing here that the user has a threshold of 2. That's why when we test the risk versus the threshold, the risk is superior. So the user needs to be nudged, but which piece of information is the system going to recommend its deletion? It's going to be social security number because it has lower preference when it comes to the user. But at this point, the user is at has 2 choices, let's say. So they either are going to accept the nudge or refuse it. So if they do accept the nudge, that means that the objective risk has been lowered because the user did delete a piece of information. And when it was lowered, at this point, it was below his threshold. And we also do like reduce the threshold because the user has displayed an aware behavior. They accepted the nudge, so they're more open to be nudged next time in comparison with someone who refused the nudge, which is the second scenario where the user does refuse the nudge. The risk remains the same because the input is still the same, and the threshold is going to be again, it's going to go higher because the user has displayed more unaware behavior. They refuse the nudge, so next time maybe we're not going to nudge them about the same thing with the same threat level, let's say. So now we're going to move on to the conclusion and future work. So for the conclusion, yeah, so there's no doubt that the level of self-disclosure in these days is getting higher and higher, with everyone like sharing their photos on social media without even a second thought, which was not the case before. And the one-size-fits-all, such as campaigns or any type of solution that is not aimed at someone in particular, so at the public in general, they have not shown very promising results, as people still behave the way they do and their records are still being disclosed all the same. So there's a need for a balance between the mitigation of dangers, but also help users achieve their goals. So we're not going to ask people to just stop sharing altogether and cease all activity online, because in these days that's not doable. That's why our work falls within the scope to tailor nudges for a personalized guided experience that, yeah, it's personalized because it's in accordance with the user's own, let's say, preferences at this point. At a later point, we're going to include other parameters. So for future work, we need to consider certain things, such as the risk of disclosure, let's say, over time, because at this point we nudge the users based on what they have as an input at this moment. We don't consider like what they have revealed so far. So maybe at this moment they're revealing something minor that falls less than their threshold, but it's actually yeah, if we combine it with previously revealed information, it's more. And also we've got because for the objective values we needed like something mathematical, like certain values, so we used statistics and we averaged them and then normalized them, etc. But we've started actually studying the economics of privacy and cybersecurity in order to come up with, let's say, more, less to do with statistics and more mathematical approach. And also we're very concerned about multi-party privacy. So the user does not only reveal things about themselves, but also about others. And that is very important to consider, because someone might consider themselves to be cyber aware, let's say, or they have nothing online, but because their acquaintances share pieces of data about them, they actually have like a comprehensive profile that can be revealed. And also we've got, we have, at this point, we haven't focused a lot on the natural language processing part, and that is something to consider for the immediate future. So yeah, thank you for your attention.
Thanks, Rim, for your presentation. We have a few questions for you.
Yeah.
First, regarding the data collection process.
Mm-hmm.
How did you manage to do it? How did you manage to get the information from the dark web? Are you planning on any other source?
I didn't get the information from the dark web. I got statistics from Experian and from TransUnion, who have collected this information. So I got the information from their reports, let's say.
Okay. And regarding the recommendation, yeah, sorry.
Yeah, that's it. Go ahead, please.
Okay. Regarding the recommender system, is expected to work on only one platform, to be cross-platform?
At this point, there is no constraint to make it just one platform. We haven't made it universal, to be honest, but that's the intent. Like, the intent is to make it something that is that works across all platforms with the user's permission, of course. The user needs to give us permission to have, because it's sort of, we're going to monitor the user's activity to a certain degree in order to be able to analyze what they're writing. So there's a degree of legality and ethics that falls within this. But yeah, if the user does give us full, let's say, full rights to get their activities, then yes, it's supposed to work across platforms.
Did you do any experience with users, or have you checked with them what they think about this or these kind of recommendations? Are they willing to share their information?
No, we did it on a minor scale, but we haven't we did it from we asked people within the university, for example, but we haven't made it we haven't made a survey on Mechanical Turk and asked random people at this point. No, we just asked people in the local environment.
Okay, but are you planning to do that kind of studies?
Yes, before we make this available to the public, yes, because we need to see, for example, how different demographics of people react to this. So maybe older people are not more likely or are less likely to give us these rights. So we need to approach the problem with different perspective than with, let's say, teenagers. So yes, that is crucial to us.
That's great. Okay, thank you, Reem.
Thank you.
Okay, so we have reached the end of the presentations. We want to thank you all for being here, for making this workshop successful. We want to do a special thanks to Barbara and Marta, our invited speakers, for their great talks. We want to thank the authors for the valuable contributions, and thank Husara and Pablo for all the organization efforts and for making this workshop possible. Just a quick announcement, we are also co-editing a special issue on the Pervasive and Ubiquitous Computers Journal. If you want any additional information, you can just reach to us, send us an email. So thank you all.